Hey everyone, in this video, let's take a look at question 22, generate parentheses on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given n pairs of parentheses, and we want to write a function to generate all combinations of well-formed parentheses. So let's take a look at the example here, and even before we do that, just note that whenever you're asked to generate all forms of something or generate an exhaustive search, every type of something, then you want to often think of recursion. But more specifically, backtracking. So we've done this in our subset question, we've done this in our permutation question, all these types of questions when you're asked to generate all sorts of things, like all combinations, all permutations, etc. Then you want to kind of think of backtracking. So I just don't want you to think of backtracking right off the bat, like really understand why it makes sense. So you can watch the older videos for that, but quickly, I'll go through this one, like why it might make sense for us to do this. Well, consider the case like when we're asked n is equal to 1, right? So what are some of the things we need to understand first of all? Well, let's think of our base condition, right? Like when we are generating parentheses, how do we first understand whether it is well formed? Like what does it mean for it to be a well formed parentheses? Well, I think right off the bat, first of all, we can see from here that the length of the parentheses, right? Like the length of the string that's generated, it's equal to 6, right? It's equal to 3 times 2. It's equal to n times 2. And if you think about it, that really makes sense, right? Because for every opening, there's a closing. So basically, there's like n pairs of 2. And so that's one thing, right? So a well-formed parentheses will have 2 times n length of string, right? That's one thing. What else? Well, if we take a look at this one, remember what I just said. Every opening parentheses has a closing pair. Every opening one has a closing pair. So if you really think about it, the number of opening parentheses has to equal the number of closing parentheses. Same thing here. There are 3 opening parentheses, which means there are 3 closing parentheses. So left parentheses, so number of left one, is equal to right parentheses. That's another thing. And you notice here that like we're only generating a valid set of parentheses, right? Like how do we know like how to generate a valid set of parentheses? Well, if you were to kind of just jot this down on paper, and I just told you like generate all parentheses of length, maybe n is equal to 2, right? Or maybe let's just start off with n is equal to 1 to kind of arrive at a more general case. Well, n is equal to 1. Well, what's the first thing you would do? Well, first thing you would probably do is you would note that if the string is empty, if we haven't generated anything, then we have to generate a left parenthesis, right? Because we can't start off a parentheses group with a closing bracket. It has to start off with an opening one. So if something like that, so if left is equal to 0, then generate a left parentheses, right? So that's one thing. Now, if left is not greater than equal to 0, right? Let's say left is equal to a number like I don't know, like something like 1, for example. Then what can we do? Well, we can generate more left or we can generate more right parentheses. So how do we know like which one to generate? Well, if you just take a look at this one, right? So let's say we generate, let's say we keep track of left is equal to 1, right is equal to 0, and we generate just something like this. Now, what do I have, right? Like, what can I make my choices off based off of? Well, if I have the left one, then I can actually generate more left like this. I can actually just close the group and I generate a right parentheses just like this, right? So I have my choice here. So I can do something like if left parentheses is greater than right parentheses, then generate left or right. You can see here that left is equal to 1, right is equal to 0. Under no circumstances should we have right greater than left, because then you'll have something like this, which obviously is not valid. So in this case, we can generate more left parentheses. We can also just generate a right parentheses anytime we want. So that's one thing to know. Now, what about the case when like left is equal to right? So if left equals right, right? So if you had something like this and then we had something like this, well, in this case, we have something like this. Can I generate a right parentheses? Well, I can't, right? Because this group is essentially done. So in order for me to start a new group, I would have to start with a left parentheses like this. And so these are like the 3 rules that we'll use to generate all sets of parentheses. And if you really think about it, where backtracking comes into approach here is if we go ahead and generate, like let's say we have n is equal to 1, right? So maybe we go ahead and we generate something like this, and then we generate something like this again. Well, now we see that this is actually invalid, right? Even though like based off of our rules, we did it. If we had left greater than right, which we do, then we generate left or right. Maybe we decided to just generate a left initially. Well, then we can see that this is false. So then we'll go ahead and pop from our list. And now we'll go ahead and generate the right set of parentheses. And so that's where like the backtracking part of this comes from. But most of the time when you see like generate all or whatever, it is most likely like a backtracking type problem. So let's take a look at how we can do this. And I like to have my like formula that, or not formula, like a structure to the code that I like to follow with this. So what I do is I create a result variable, and this will store like my final set of results. Then I have my helper function, which will add to my result, and then I return my result in the very end. Okay, so my helper function will basically append to result, like the set of valid parentheses. Okay, so let's take a look at what we need passed in. Well, we need passed in n, right? We need our result passed in. We need like our cur, which will be like our current list of like valid like parentheses, like the string that we're forming. Well, what else do we need? Well, we argued here like this is how we would generate the list of parentheses, right? Like how we understand what to generate next. So here we need like a count of left set of parentheses and right set of parentheses. And I think that's pretty much it. That's all we actually need here. So what can we do? All right, so first let's start off with the base case. And we already argued that this should be the base case here. So we can first of all just check if length of parentheses, or not length of parentheses, if length of my current string is equal to 2 times n, well, then it's possibly valid, right? So it's possibly something like this, but it could also be maybe something like this. So now we just need to check our other case where if left is equal to right, then we can append it to our result. So we can do .append, and here I'll do cur, and then our cur will actually be like a list here, right? So instead of just generating a string, I will actually just generate a list, something like this, and then this, etc. So I need to actually convert this to a string. So I will do something like join cur, right? And because we are not like doing this off of a list, we actually don't need to do anything like this, but we can. It doesn't hurt really. But we'll fix this in the very end with like a more better approach here. And then basically we can just return, right? Whether or not like this was true, we can just return because anything greater than 2 to the n will not be valid. So now we have our set of cases that we can handle to generate parentheses. So we can do if left is equal to 0, if left is equal to right, if left is greater than right. But what about the case where left is equal to 0? Well, in this case, we have to add in a left parentheses, right? So we will add in a left parentheses like this. Then I will do my helper call, and I will fill this in, and then I will pop. And this is how we do our general backtracking type problems. Similarly here, we have to do the same thing. If left is equal to right, we can only generate a left parentheses, so I'll space this out actually. And then in this case, we can actually do 2 of them. We could either generate a left parentheses, or we could generate a right parentheses. And so what should we fill out in this helper? Well, n stays the same, result stays the same. Cur, we just appended it here. Left, we increase by 1. Right, the count of right parentheses remains as it is. So this one we can actually replace here and over here. And here, the only thing to change really is instead of left, we will right by 1. And that's basically all there is to this. So we will now go ahead and append this. We'll do n, we'll do res, cur initially, let's set it equal to empty. Left is 0 because there's 0 left. Right is also 0 because there's 0 right. And now let's go ahead and run this. And it passes. Let's go ahead and submit this. And we see it also passes. So this is one way of doing it. The other way, because we see that we don't actually need like a list, right? We can just maybe treat this as a string. So if we want to do that, then one thing we could do is instead of just joining here, let's assume cur is a string. So instead of here, we'll pass in it as a string. Here I can just do cur. Here I will do cur, and then I will append the left-hand side parentheses. And I would do the same thing here, append the left-hand side, which means I don't need to pop it, right? Because the string, once we go back, it'll be its old version. We don't need to pop it from the list. And so we can do the same thing here. And then here, we'll basically just do the right-hand side parenthesis. And then I will change this left to be just left, and then right will be right plus 1. So this is another way in which we can do it. And we'll go ahead and click submit. And then that's it. So what is the time of this? Well, if you think about it, we can generate like 2 to the n type parentheses, right? Because like at maximum, like we have 2 options here. So it's 2 to the n in terms of time and also in terms of in terms of space. Really, you can think of it like that as well. Because like that's how many recursive calls we're doing. And like, yeah, just discuss with your interviewer like how they want to analyze the space. It's often like difficult for these types of problems, but yeah, I hope this helped. And remember the backtracking formula that we use and the code that we always write for backtracking. Yeah, thanks for watching.